Welcome to part 2 of the 5-part series on domain-driven design with our guest speaker, Michael Plod of InnoQ. Please feel free to ask any questions throughout the session, and we hope you enjoyed today's webinar. Now I'd like to turn the session over to Michael Plod. Michael?
Yes, thanks, Amy. Thanks for having me again. And thanks to everyone attending the second part of our domain-driven design webinar series. This time around, we're going to talk about strategic design, aka the big picture. Let's quickly review the webinar series. A month ago, we've been talking about an overview of domain-driven design and the values and the core attributes of domain-driven design. That means that DDD is not just a technical kind of thing and not just a collection of patterns. There are patterns, there are technical aspects, but domain-driven design obviously also covers quite a few organizational, communicational, and language topics such as the ubiquitous language, for instance. Today, we're going to take a look at the bigger picture. We're going to take a look into domains, subdomains, bounded contexts, and context maps. And I think today will be especially interesting for those folks that either plan on going towards a microservice-based architecture, because the microservice community often says, okay, structure your microservices along bounded contexts. And I think there is quite a bit of truth to that sentence. And we will obviously cover that as well. But today is also going to be interesting for people who do have a, let's say, monolithic, grown legacy architecture and that want to evaluate this architecture, and especially when they want to transform this kind of architecture towards a new design, be it microservices, self-contained systems, or something else. This is the ground that we're going to cover up today. In a month, on the December 12th, we're going to talk about tactical design, aggregates, entities, value objects. That means we're going to look into the structure of bounded contexts when we implement, let's say, a microservice, how the inner parts are going to look like. And on the fourth part, on January 17th, it's all about event-driven architectures, domain events, event sourcing, and event storming as a workshop format. And the fifth part, on February 15th, will be about implementation aspects. The fifth part will be about code. And we will look at how we're going to bring all of these things to life using the technologies from the Spring ecosystem, such as Spring Boot, Spring Data, Spring Cloud, and so on and so forth. Let me quickly mention also the Spring One Platform Conference, which is taking part in December at the Moscone Center in San Francisco. I unfortunately won't be there, but as far as I know, there's going to be a workshop and presentations by Vaughn Vernon, who's obviously a very prominent person in the DDD community. So make sure to check that out. Just a few short words about myself. My name is Michael Plod. I'm working as a principal consultant at a company called InnoQ. We're basically a software development architecture consulting company based in Germany. I'm based in Germany as well. I'm a regular speaker at several national and international conferences. You can also follow me on Twitter. My account name is @bitboss, and make sure to check out my GitHub repository for code examples and stuff like that. And I'm currently also writing a book on domain-driven design. Actually, I wanted to release the first chapters this week, but I'm not there yet in terms of the quality. So sorry for everybody who waited for a first drop this week. I'll probably push that into December or Q1 in 2018. Sorry for the delay, but I want to get it right, and I don't want to release some mediocre stuff for you folks to enjoy. Now, without further ado, most of these things were not, let's say all of them were not invented by me. The props go out to Eric Evans and Vaughn Vernon, who released 2 really excellent books on the topic. The one is Domain-Driven Design, aka the Blue Book, and the other one is Implementing Domain-Driven Design, aka the Red Book. So make sure to check those out if you haven't already. Now, without further ado, let's go into the part of strategic design. And obviously, everything starts with domains. Domain-driven design is called domain-driven design because it says you should derive your software architecture and the implementation of your software from your business requirements. So basically, the heart of the domain should be reflected in the software you're writing. And usually, teams are working in certain business domains. And this domain should be the core focus of a given team. However, in my opinion, if you ask various stakeholders of a project or of an organization what their domain is, you may get different answers. One answer, if you, for instance, ask a CEO, they will give you a very broad domain name. For instance, if you ask a CEO of a, let's say, car company like the Volkswagens or the Chevrolets or General Motors or Teslas or whatever in this world, they will probably give you, say, well, my domain is mobility or something like that. Now, a car maker usually consists of various sub-organizations. Most of the big car companies also have banks that offer leasing and financing contracts to potential customers. And if you ask the chief of the car bank, they will probably tell you, well, my domain is banking and not car making. If you ask the chief of the factory plant, they will tell you, well, my domain is car production or something like that. So there are a lot of examples for domains. It can be banking. You can be focused on mortgage loans, on credits, debit accounts, credit cards, retail loans. So with the domain alone, we do not get very far. And that's also the reason, and this is also a part of a typical, I would say, enterprise architecture business. We also talk about subdomains. And you can structure any domain in a given amount of subdomains. And this is something that is happening at a lot of large organizations. They make domain and subdomain models, and what they driven by the business. And what they then do is that they put applications that they have, so existing applications, on this model, and they try to see how these applications fit into the view of domains and subdomains, and so on and so forth. Now, this is nothing, I would say, really revolutionary. This is, in my eyes, also the black and white box modeling that you usually do there. This is a typical, I would say, enterprise architecture business. However, domain-driven design adds, I would say, another spicy ingredient to that, and that is the classifications of the subdomains. Domain-driven design sees 3 classifications for subdomains: the core domain, the supporting subdomain, or the generic subdomain. And what they also, or what the DDD community also suggests is that you should organize your staffing or your project delivery according to those subdomains. For instance, in the core domain, you want to have your best teams, and you obviously want to have internal teams. Interesting enough is that me as a consultant, I've seen quite a few, let's say, violations to that rules. For instance, I worked at a bank that had a big mortgage loan system, and they completely outsourced the development of that system to an external vendor. And well, the problem is they said, well, we don't even want to have any rights on the source code here. And when they ran into problems, you always had to struggle in order to get to the source code of the system in order to find out what's wrong, because they basically said, hey, we're going to buy that as a product. And well, that's obviously not the way it should be. On your core domain, you want to have a lot of possibility for differentiation against your competitors. You want to be different. You want to have a really great product in this domain, because that's where you are competing in the market. However, not everything in an organization is part of a core domain. Excuse me. We obviously have other, let's say, subdomains that are needed to operate a core domain. Without them, the core domain wouldn't be functional, and those are usually classified under a supporting subdomain. That's supporting functionality, which is not available as COTS software. COTS software is custom off-the-shelf software. So that's usually software you just buy from a vendor or some external software. A typical example for COTS software would be SAP or something like that, or even some SaaS offerings such as, well, whatever, doesn't matter. This is software you want to implement internally as well, but eventually with some external support if you don't have the capacity for in-house development. The last category is the generic subdomain, and that is something that you just want to outsource or you just want to buy off the shelf. A good example is, for instance, us as InnoQ, we're a consulting company, so we are obviously traveling a lot. So travel expenses are a thing that we sort of need. Do we need a travel expense software in order to operate in our core domain? No, obviously not. So we just buy a product off the shelf, and we're using that. We could actually use an Excel spreadsheet as well, but we did that and it was a little bit cumbersome. So the generic subdomain is something you just need, but with not so much impact on the core domain. So there you want to set up your organization a little bit differently. Now let me show you an example. For instance, let's say our domain is automotive, and we have the subdomains logistics, finance, production, marketing, external traders, research and development. And this is a typical white box, black box kind of thing. Automotive is in a white box manner. We can look into that box. But for instance, research and development on this level, on the first level, is a black box. Now let's drill into the research and development, and we see like design, production planning, engine development, development for infotainment system, assistance system, testing of the car's CAD systems such as CATIA, for instance, and we can even drill further down on those levels. But to be honest, obviously we could drill down these things towards a 5th, 6th, or 8th subdomain level, but I don't think that is a real benefit for us. We need something more, and this is where I would say the real specifics of domain-driven design, of the strategic design, come into play. in my eyes, domains and subdomains are important, but they are I would say, no real new kind of thing in the DDD world. But the bounded context and the context map with all its patterns, they are a core part of domain-driven design, and especially the thinking of domain-driven design. And in my eyes, especially the bounded context is a really very interesting thing when you want to do something like microservices, or when you ask yourself, well, I want to do microservices, but I'm not really sure how to structure them on a business level. Which functionality do I want to have in which microservices, and where are the boundaries? How do I get really independent microservices? And this is a thing where the model of the bounded context really comes into play and gives you a real added value. Now, I would say let's check out what this mysterious bounded context is all about. Basically, this is basically a quote from a DDD book. Every sophisticated business domain consists of a bunch of bounded contexts. So this is, in my eyes, a further drill down from a subdomain towards a newer level. There are some, I would say, some diagrams in some books and some literature that have bounded contexts that span various subdomains. I personally think you should, especially when you follow a greenfield approach, you should aim at scoping the bounded context into one given subdomain. But reality in software projects is often really ugly, so sometimes we find certain bounded contexts that span various subdomains, but that would be something that I would take a closer look at. Each of those bounded contexts contains a business model and could also contain other bounded contexts, whereas I personally think I wouldn't work a lot with nested bounded contexts, to be honest. I like to keep things clear and simple. The last sentence on that slide is, in my eyes, one of the most important sentences in this presentation. The bounded context is also the boundary for the meaning of a given model. What does that mean? It means that we take a very strict look at the model within the boundary of a bounded context, and that we try to find the perfect representation for a certain business model inside a bounded context. And this is something where DDD really differentiates itself from other, I would say, approaches to software architecture like service-oriented architectures. In the service-oriented architecture space, you usually have this one certain central customer service, for instance. And this service contains the true model of a customer, and it applies to the whole subdomain or to a complete application landscape. So this SOA kind of model promotes a, let's say, a centralized view, whereas I think the bounded context promotes a more or less a decentralized view, that we can take a look at a customer in different ways. Now, let me give you two examples to really clarify that. The first one, let's do a system for managing a conference, such as the Spring One platform conference, for instance. And we have identified three bounded contexts: reservations, event management, and badges. And there comes our customer. There the customer comes. And, well, this is a person that stands in front of us. And in the reservations, people usually sign up for the conference. So you say, yes, I think Spring One Platform is an awesome conference in a great venue, Moscone Center in San Francisco. I want to go there. I talk to my boss, and I register for the conference. Now, in this bounded context, we could model the customer in a way that is, I would say, typically CRM, a typical CRM sort of a model. I'm no CRM specialist, so maybe I'm wrong, but if I ask a student, draw me a UML model of a customer, that would be something that might actually appear there. Now, the second context, event management. Well, this context tries to manage the event. For instance, the catering. We need to know, first of all, how many people we are awaiting for the conference. It doesn't make sense to prepare 1,000 meals for a 100-person conference. But we also want to avoid that there is not enough food for the people at the conference because they get grumpy and they rant around on Twitter. And we also want to know, for instance, how many vegetarians, how many vegans, how many meat eaters, and whatever we have in order to adjust the catering. The next thing that we want to know there, which speakers draw a big crowd with their talks, and which speakers don't draw a big crowd, or they have a very specialized, nerdy sort of a topic, and so we can put them into a small room for intense discussions and whatever. So basically what we want there is session registrations and lunch preferences. Now, the model for that, do we really care for the customer in person, for a centralized model of the customer in this context? No, we obviously do not care about that, because what I always say is when you try to figure out what a suitable model for a given bounded context is, try to think what you would do in an analog process. What would we do in terms of session registrations and lunch preferences? We would go to a whiteboard and draw a couple of lines. So one customer is a vegetarian, another is a vegan, another one eats meat, another meat eater, another vegan, and whatever. So obviously, this is also a suitable model for this context. We do not care if, for instance, Michael Plod, as a customer, eats meat or if he prefers a vegetarian diet. It's just, I just get reduced to a line on a whiteboard in an analog world. Now, the next context, the badges, that is actually a little bit more tricky. On the badges, you usually, folks of you in the webcast who've been to conferences know you usually get a badge with your name, like the company you're working for, a job title, and for instance, a Twitter handle. And we have the name, and the name in this context, well, should be the same as in the reservations, but does it have to be? Do we really need to tightly integrate the name here? Or could we, let me give you an extreme example here, could we just print out a list of reservations on a piece of paper and hand it over to a bunch of students who just create the badges in a badge printing system? So that means a total separation here. I mean, what could go wrong in this case? My last name, Plod, if you replace the P by a B, in German it would be blöd, which translates to stupid. So I could, in the worst case, get a badge which says Michael Stupid on it. I mean, what could I do? I could rant and be angry at the organizer, or I could say, well, no worries, just replace the badge. So we can make an educated decision here. If we want to work with, a central data set, or if we want to work with, let's say, replicated sort of data. There is one question here from the audience. I'm going to pick up some questions that really fit to a given slide during the talk. One person in the audience said, I think the customer should be in a separate bounded context which will be used by the other bounded context. This is, in my eyes, an option that you can do, but then you run into the risk that you create a certain structure that I would say that is coupled to a lot of other bounded contexts, and this centralized structure can actually be a blocker for quick releases and quick independent releases, especially if you work with microservices. I wouldn't say your idea is wrong. It is valid, but it is one option among many options. But it is a valid option. You have to make an educated decision here. Now, let me give you another example, which is not data related. Let's take a look at a car. And I have two contexts, personal driving and service center. Now, one option or one implementation option that I could do is I could go ahead and model in the personal driving car get engine dot start. Would that be a valid model for the car in this context? I highly doubt that it would be a valid model. Who of you is dedicatedly starting their engine in their car? No one. We all start our car. So I think car.start would be a way more suitable model in this context, because there we actually know the car then knows, okay, I have to start the engine, I have to start the ESP system, the infotainment system, the GPS, the whatever light engine, and so on and so forth. So take a look into that. There is actually a law around, the law of Demeter. I'm not a very big fan of calling it a law, because a law means you always have to comply with it. I would like to rephrase it to the hint of Demeter. According to the law of Demeter, car get engine.start would be a violation. And if you're into that, just look it up somewhere in the internet. There is various examples. I don't want to go into a lot of details here. But I think when you're running some metrics and you have a chance to evaluate violations of the law of Demeter, a high degree of violations on that can give you an, let's say, an indication that you might want to look at your model. I wouldn't say that your software then is a full-blown catastrophe, but it might give you an indication that something might be wrong with your model inside the context. Now, in another context, on the service center side, we could easily model the car in a way more detailed way, because the mechanic in the service center takes a very close look at the car. They really operate with the engine directly. They really interact with the GPS or the infotainment system and so on. So you can choose a different model there as well. Now, let me step over that. I've done that already. Now the question is, how do I get to bounded context? How do I actually identify a suitable bounded context? In my eyes, I would take a look at 4 major drivers. I think we could do a complete webinar over an hour how to identify bounded context, but let me just summarize that quickly. The first factor that I would look at, especially if you work in terms of towards microservices with bounded context, I would say one context should be able to be managed and implemented by one team. If you need a huge team, things get unproductive. If you need, let's say, 3 teams on one bounded context, I think there is a tendency that the context is getting too big. Now, that is one indication. The next indication, the meaningful model, means I want to have bounded context that can contain a model that makes sense. So please, please, please avoid bounded context that with the name of util or software trash dump or whatever, or the name whatever, and do a collection of various things in there. Just see if there is really a meaningful model that absolutely makes sense and that is very well decoupled in there. And in my eyes, this also goes hand in hand with the criteria of cohesion. I would want to look into the cohesion a lot as well. You want to bundle functionality and a model that is highly cohesive that really fits well together. For instance, let me give you an example. When we want to, we have a context that where we can apply for a mortgage loan or for some loan for whatever, for a car or a house or something. And there are two sorts of functionality here. One is the entering of the loan by the customers, and the other one is in terms of the validation, if the application form is filled out in a valid manner, if it makes sense, for instance, if the child support has a realistic value and stuff like that. Now, I see that often discussed in trainings that I do. When I do DDD trainings, my case study is mortgage loans, and I often discuss with my participants if we should separate the entering of the form and the validation of the form into two bounded contexts. And I think, especially in terms of cohesion and the model, there is a trade-off decision, obviously, somewhere. In terms of functional cohesion, entering is something sort of different than validating, but they both basically operate on the same model. Also, think about analog processes as well. A lot of the business teams around, they really fancy stuff like design thinking workshops and things like that. And this is something where you can also get into play when you see something like that happening in your organization. Take a look at that, because they often work with analog models, with analog prototypes, and try to take a close look how they work in an analog way. And given the mortgage loan application, you see the validation and the entering both happens on the same piece of paper, the form. So I would actually tend to bundle that into one bounded context together. But it's a lot of times a trade-off decision. There is obviously some places where you say, okay, right, but, and, or it depends, and you have various options and discuss them thoroughly with the business. Another very big driver is the language. In the first webinar series, I talked a lot about the ubiquitous language. And I think the ubiquitous language is also a great driver for identifying bounded contexts here.
Michael, there was
yes,
Michael, there was an audience question that I think is germane to this particular slide. Is it okay if we?
Yeah, absolutely.
Take it right now. Okay, cool. I heard you say that earlier. So they asked, do you consider it a good idea to implement a factory pattern to create different models for different contexts? Different models to different contexts. Excuse me.
To be honest, I don't think that it is, or let's say it depends. When you work in a microservice environment, I think the factory pattern that creates a model for different contexts is not a very good idea, because I really want to have independent factories in every context. If you are working in a, I would say, monolithic context, it is easier, but actually I would still separate it, because I really want to strongly separate my bounded contexts from each other. And this factory then really goes very, very deep into the internals. It has to know the innards of various models, of various contexts, and where would you place that pattern? I just saw the question, and during giving the answer, I copied and pasted it away, and I will get back to that specific question when we are talking about the implementation on the code level in the 5th installment of the webinar series, because that is actually a really good question, and I saved it for the 5th part when we really talk about implementation aspects.
Thank you.
You're welcome. Now, the next thing that we need to take a look at is the context map. The context map brings the bounded context into relations to each other. I mean, an isolated view in terms of a bounded context doesn't give us a really good overview of a system. And obviously, in most systems nowadays are distributed, so they communicate with each other by various means, be it by, let's say, calls to REST resources, to web services, to, let's say, binary protocols or whatever. And so obviously there is a contact between systems or context and models. And this is exactly where the context map steps in. And in my eyes, the context map goes way further than just looking at, let's say, delivery relationships between systems. The context map goes deeper than the usual, let's say, enterprise architecture view of a system landscape. And this makes it a really great starting point for future transformations. And to all the folks in the audience that are dealing or planning to move a, let's say, legacy monolith or a grown system towards bounded context, I highly recommend them to take a really close look at the context map. The context map categorizes these contexts into 7 patterns. And please be aware here that the word pattern doesn't mean best practice pattern. Those are patterns that happen in the real world. And I would say in any aspect of life that you look out, patterns that happen in the real world can be nice, but they can also be really ugly. And so some of them you would say, whoa, that's a pattern, I'm surprised. Yeah, well, it is a pattern, it is ugly, but it happens in the real world. And one of the first ones that actually fall into that category can be the shared kernel. So the shared kernel, it means that 2 teams or 2 applications or 2 bounded contexts really share a part of a model in a, I would say, in a physical way. One example for a shared kernel in the Java world can be, let's say you have an RMI or a Hessian communication between 2 systems. RMI and Hessian demand you a compatibility on a binary level. So what usually happens is that those 2 systems share a jar file with the interface description and the model that is a part of that relationship. That is a typical shared kernel. I mean, nowadays, nobody really wants to establish an RMI kind of communication anymore between systems. And I rarely see this happening in my day-to-day work. Another part of another aspect of a shared kernel is something that is actually really widespread, and especially in, I would say, legacy monolithic applications. and that is the database. So I see many monoliths that share part of the model on the database. So one, let's say, vertical business slice sends select statements to the tables of another slice. And this is something that you really see very often, and it is a shared kernel. The next three patterns, customer supplier, conformist, and anti-corruption layer, are patterns that you usually find on the so-called downstream system. The downstream system is the system that is calling an upstream system. So, for instance, I am a bank, and I want to ask a credit agency for the creditworthiness of a given customer. And so I send a request, let's say, to a web service interface, and the web service responds to me with a model. Now, the credit agency is the upstream system. I, as the bank, am the downstream system. So you have to take a look at that from a river's perspective. For instance, a river is flowing from city A to city B, so city A is upstream, city B is downstream. If you put, let's say, a bottle into the river, it floats down the river, so it floats downstream. Now, the customer supplier on the downstream side is a team that discusses the model with the upstream system. So they obviously have a veto right on the model. So you often see that when you want to change the model of an interface or the model of an upstream system, and the upstream system says, hey, we want to migrate our model to a new version, and some consuming systems in a meeting get into panic mode and say, oh, you can't do that. We don't have any capacity to adjust that. And when they can block the upstream system from advancing their model, they are in a customer-supplier relationship. A total different kind of thing is the conformist. In the conformist, the downstream system just takes whatever they get from the upstream system. And there can be various motivations or forces for being a conformist. One motivation can be that you really like the model from the upstream system. You think this model really fits your needs, and then you go for that model and you adopt it. The other way can be that you are forced to use a centralized data model in your given organization, and that means you have to be a conformist. Another way is that you do not have any power. For instance, if you integrate with Google Maps, you are obviously sold on the Google Maps API. There is no way for you to get around that. You can't call Google and say, oh, can you change your model for us, please? You wouldn't even get a reply, I assume. So they just say, move to trash, def null. Now, to summarize that, the customer supplier discusses APIs and the model with a legacy team. For instance, if we integrate with a monolith, and they can have veto rights. The conformist is a way that the legacy team only provides what they have, and you are forced to consume what you get. A way to get around that is by using an anti-corruption layer. The anti-corruption layer is also usually found on the downstream side, and it is one layer that transforms an external model to your internal representation. And this comes in, I would say, really handy, and this is something that I would always do when you're working in a greenfield environment. So this is something that I would actually want to see in any newly developed system. The next pattern that we have is separate ways. Separate ways means there is no, I would say, physical connection between two systems. You remember my example from the registration to the badges system when I was discussing bounded context, and I said, hey, what about the registration system printing out a piece of paper And there is a team of students that types in those names and creates those badges. That is a typical implementation of separate ways. So there is no, I would say, physical coupling on a systems level, but you find I would say, a coupling on an analog or an organizational process kind of level. This happens really often, especially in grown systems, and you need to account for that. I mean, there is a big room for improvement here, also when you plan for a transformation or something. The next pattern, the open host service, is, I would say, is something I would call an upstream pattern. It means the upstream system goes ahead and provides a dedicated interface to its internals, or the context provides a dedicated interface. So in the moment where you have, let's say, a web service or a REST resource that you are publishing with Hatos or whatever, you have an open host service. And that's all there is actually to say about that. And the last of those patterns is the published language. And it is quite similar to the open host service, but it goes a little bit further because it doesn't it doesn't foresee a, let's say, a real interface. It describes more or less, it is a published language. It is a parts of the ubiquitous language that are mandatory for all the contexts. For instance, in the case of a mortgage loan system where we have a context of, let's say, entering the form, scoring, credit decision, payout, or something like that, the account number and the semantics of the account number would make up for a really good part of the published language. And you really want to keep this tiny and precise and small. You do not want to have a global published language over everything, because then you would end up with a global data model, which I would say hasn't been the biggest success story in the IT industry. Now, so far for the theory, let's take a look at an example. Here we have, let's say, a really tiny and lousy e-commerce system consisting of 5 bounded contexts: payment, warehouse, logistics, online ads, and the shop. Now, these are calling each other. There are, let's say, communication flows going around. And I mean, so far, we only see call stacks here. So shop is calling payment, shop is communicating with warehouse, warehouse is somehow communicating with logistics, and shop is also communicating with online ads. Now, when you want to get started with a context map, the first thing that I would do is I would identify upstream, downstream relations. And then I would look for open host services. So obviously we find dedicated interfaces on the payment side, on the logistics side, and also on the online ads side. The next thing, I look at how these interfaces are being handled on the downstream side. So for instance, let's say FedEx is our logistics provider. They provide a web service, and warehouse is a conformist to the model of FedEx, which means they are a conformist. They run on the model of FedEx, and they are tightly coupled to that model. The next thing we identify, the shop is taking, the shop team is taking a lot of influence on the model from the online ads team. So the online ads team actually wanted to further develop their model, and they couldn't do that because the shop team always raised the veto flag. And we see that the shop also implemented an anti-corruption layer towards the payment context. For instance, the payment providers had their own model, and this got translated to a shop internal, more generalized kind of model. Unfortunately, during drawing the context map, we found out that the shop system isn't interacting with the warehouse over a dedicated interface. It's sending select statements towards the tables from the warehouse. Now, That means we have a database-driven shared kernel here. Now, the bad part of this thing here is the following. Take a look at the communication, the model flow from logistics over the warehouse to the shop. What we can identify here is that when we want to replace FedEx by UPS as a logistics provider, on the first view, we would say, oh, okay, we have to adjust the warehouse and we're done. But looking a little bit deeper into that relationship, we find out, oh, there is a risk that parts of the model from FedEx are propagating to the shop because of the shared kernel and the conformist relationship on the warehouse side. Now, this gives us a really, really good insight. And it also goes hand in hand with Conway's law. Because there is a difference in terms of team communication. On the shared kernel, the customer supplier and the conformist, you have a tight coupling, a tight integration, a lot of team communication. Whereas, for instance, anti-corruption layer and separate ways lead to more team independence and lesser coupling between the teams and the interest. Now, where do the context maps help us? First thing, we can identify governance issues. We can see, is one team eventually blocking another team? The next thing, we can find out bad political play on terms on the integration and so on. And we also see how eventually bad models propagate through a system, and we can create boundaries for those models that they do not get propagated ways further. This is especially interesting when you are also integrating, let's say, two-speed IT into your organization, that you have a slow-speed IT and they are still stuck with their, let's say, host-based legacy systems with, let's say, really complex models and so on. And you also want to have a higher speed kind of architecture based on microservices, all the Spring Boot stuff and so on. And you can identify, okay, we really have to draw certain boundaries in order to keep the high speed on the new stuff up and running. And this is an excellent tool for planning transformations, especially when you say, okay, I have an existing landscape and I want to transform that, I want to modernize that. This is a really great risk management tool that can show you really nicely things that can obviously go wrong here. I mean, to summarize that, strategic design in my eyes consists of the idea of domains, subdomains, consists of the idea of bounded context and on the context map. We have actually added a poll in the votes section. And I would be interested what you think is most valuable in terms of the strategic design part. Is it the bounded context? Is it the idea of the context map? Or is it the subdomain classification? So if you want to cast a vote, feel free to do that. I would be really interested in getting a view on your opinion here. Now, that's it basically from my side also. Now, we talked about domains, subdomains, bounded context, and on December 12th, in, well, less than a month, we will look into bounded context and see how we can ramp up a software architecture in those bounded contexts. We will talk a lot about entities, about value objects, repositories. We will talk about hexagonal architectures and stuff like that. And this is going to take part in December 12th. And we will also have another installment on January 17th and February 15th. Quick hint, I'm also writing a book, you know, and if you're in Germany and if you're in Austria, Switzerland, and if you speak German, I'm going to conduct a public DDD training in Berlin on December 27th. A link to the training is also in the links section. Now, I'm going to hand over to Peter, who eventually has a couple of further questions and further remarks for me.
Sure. Yeah, absolutely. So the link for the next installment in the series is already should be already being displayed on your screen. So there's a registration link for that next one. And then Michael mentioned obviously there's further webinars beyond that as well. So if you're looking for those as we get them up and on the website, they'll be located at content.pivotal.io. Now would be as you're done voting. Once you're done voting, now is a good time to go to the attachments and links section of the user interface, that tab. And then there's a whole bunch of good stuff there. So Michael was kind enough to put a few things in his GitHub repository. You can sign up for the book release notification and do other fun things like follow Michael on Twitter, which I can say from personal experience is definitely worth it. Michael, thanks so much for doing this again today. There was one or two other questions from the audience. There was one where the person was curious, at what level is the transformation done for the different bounded contexts? So if customer is represented differently in reservations and event management applications, how are the data formats and schemas handled?
Well, basically, I think if you, it depends on the direction you're approaching it, and this also goes hand in hand with the second question that just came in, and I will answer them both together. The second question was, what is the value of the context map in case of a greenfield approach? Now, if you approach this on a greenfield perspective, I would highly look into the anti-corruption layer and eventually separate ways. In my book, I'm going to allow myself to add another way of classifying it, and this is also part of the fourth installment of the webinar series. When you work with event-based things, you can basically work event-based with an anti-corruption layer as well on the model, and this is something we're going to discuss in the fourth installment here. And so in a greenfield approach, anti-corruption layer is the way to go there. In a integration or in a transformation approach, you have to see what is happening and how you can break things up. Do you have a customer-supplier relationship? Do you have a conformist relationship? What are the reasons? And what is obviously the best solution given the current governance and political and organizational situation that you are in? Another question, which is really interesting in my eyes, can a bounded context have a back-end and UI code? I would say it depends on the way that you want to set up your, I think when you work with microservices, when you want to set up your, how you want to set up your microservice architecture. There's various flavors of that. I actually favor the microservice style called self-contained system, and a self-contained system is basically matched upon one bounded context, and it does contain back-end and UI logic, and we do the integration on the UI level. We will also take a look at these aspects in the fifth part when we talk about implementation details. But I would favor that. But there are also other ways like back-end for front-end, like the BFF pattern and stuff like that, that separate these things. I actually prefer keeping them together on a code level.
Gotcha. Okay, I think, folks, if you have any other questions, now's the time. I think that exhausts the current queue. And it looks like people have been voting while we've been talking. And it looks like context map is the winner at 53% in terms of the most valuable aspects of strategic design. Bounded context coming in around 40%. Subdomain classifications around 6%. So interesting. Thanks everyone for the feedback.
Very interesting. I actually expected the bounded context to win.
Me too. Me too. I always thought that was.
But Very nice.
Heard that was
very nice.
Yeah. All right. Well, excellent. Take a chance to register for the next installment in the series. The link should be displaying to you right now. And then the replay for this will be, this event will be available at the exact same URL that you used to register. So again, that content.pivotal.io URL that you used to register for this event, the replay and the slides will be posted there so that you can share that with your colleagues if you like. Okay, Michael, I think that's it. And of course, if you all wouldn't mind taking a moment to give Michael some feedback, you can give him just a simple 1 to 5 star rating on how you found the presentation today. It seems like a few people have already done that. So again, thank you. Yeah, a couple of people saying thank you, and one person saying, it's my opinion that you need to have well-defined bounded context before you can accurately represent a context map. Both are valuable in strategic design, and I feel they both need to be addressed. So I guess more of a comment than a question.
I tend to agree with that, but I actually, I mean, this is absolutely correct in my eyes as well, but I actually use the technique of context maps in projects where these contexts are not yet clearly set in stone. And when you start with, let's say you have a monolithic application, and the monolithic application is structured in, let's say, horizontal technical layers, and let's say those vertical business kind of modules. And I actually start looking at these things on this level already in order to then be able to define first, let's say, boundaries for future bounded contexts when we want to modernize or transform this kind of application. I made some really good experiences in doing that, but this is, you can approach it from, I would say, 2 ways as well, but there is nothing wrong with that sentence as well.
Very good, Michael. Sorry, I was on mute. All right, I think that wraps it up. Everyone, thanks for taking a minute to vote. Give Michael some feedback on the webinar. Really appreciate that, as I'm sure Michael does. And we really look forward to seeing you on the next installment on December 12th. So please come back and join us then, and tell your colleagues about the webinar series, and get them to come along. We'd love to see you. Okay, Michael, anything else you want to say before we call it a wrap?
Well, no, actually, thanks to everybody for attending. Thanks for the really kind and warm feedback that I have from you folks. I really appreciate that, and I hope to see all of you, or most of you, on the third part on December 12th.
Awesome. Looking forward to it. All right, take care, everyone, and thanks for your time.